or 8 all about quadratic inequalities. So let's see, we want to be able to graph and solve quadratic inequalities after this, right? So sorry, this picture is so big. We're going to follow the same process as with linear inequalities. So we're going to graph them as if it were an equation, and then we'll have to think through solid versus dashed line. And then we will have to test a point that is clearly on one side by plugging it into the original, and then we'll shade inside or outside of the parabola. Okay, so think about this. We have all these new graphing skills with parabolas. Remember, the best thing to do is to find its vertex first. Okay, so you can either use negative b over 2a, or if you really want to, you could rewrite this in vertex form so that you could read the vertex right off. I'm going to use negative b over 2a because I think it's quicker. Okay, so negative 2 over 2 times 1 will give me negative 1. Okay, so I'm going to make an xy table. I know that the x value of my vertex is a negative 1. I'm going to go up a couple, down a couple. All right, and then I'm going to fill in this table for us. Okay. And then we're going to graph it. Let's plot these points. Negative 1, 0. Negative 2, 1. So we're going to open up. Right, and we're going to look something like this, but instead of sketching our parabola like normal, we need to look at the sign, right? So this is a greater than symbol, meaning that we're going to need a dashed line. Dashed line, okay? So let's draw our dashed line. It's still going to be a parabola type shape. If you would rather, if it's easier for you to draw the line as solid and then just erase along, that is fine, right? And then now we got to pick a side to shade. Are we going to shade above the U or below the U? We can look at the sign, see that it's greater than, which tells us that we're gonna want to shade above. If you struggle with that intuition of how this is above, then you can just test a point, right? So the origin is very clearly outside, it's very clearly underneath that parabola, so let's plug it in. 0 is 0 greater than 0 plus 0 plus 1. Is 0 greater than 1? No. So we want to shade the opposite thing. We want to shade not the region that includes the origin, right? And so our graph will look like this. Not too bad. Pause the video, excuse me, give this a try. All right, hopefully you found that your vertex was negative 1, 3. Go up a couple, down a couple, and we get some points here. All right, let's plot our vertex over negative 1 up 3, and then over here, and then something like this. And then we see that we have a less than or equal to symbol, meaning we're going to have a solid line. That should look something like this. Do we shade inside or outside? This less than or equal to tells us we want to shade below. If you struggle with that intuition, just plug in the origin. Let's see, is 0 less than or equal to 0 plus 4? Is 0 less than or equal to 4? Yes, so we want to shade all this out here. Everything below that parabola. All right, try this one. All right, let's see. Our vertex, we're going to have some fractions here. Fractions are our friends, even though we don't like them. So if we take negative b over 2a, we're going to get that our x value of the vertex is 3/4. And when we plug that in, we're going to get, I'm going to write this as a decimal just so I can like plot it appropriately, 6.125. And then we need to be careful here. If we're going to go up 1, we need to go up to 1.75, right? That fraction needs to carry along with us. I know I'd always tell you that I like fractions better, but right now it's actually going to be easier to graph this if we use the decimals. And if you struggle to understand why these are going out each one from the vertex, then that's more of a numerical sense conversation. It's not really a parabola conversation. 4.125 and then negative 1.875. So this bad boy is going to open down. All right, and then let's see. yeah, I don't feel like plotting these points. So plot the points. You'll end up with something that's like roughly this way in shape, except it should be dashed, right? So let's see. If I plot right here, roughly there, and then I'll go out just barely down, and then something like that. We're going to be looking at a parabola that's something like that. Okay, and then we're going to shade below. Okay. All right. So to solve these algebraically, we can follow this process, right? In general, the process that we're going to follow for these is it's just asking us, like, where is the parabola above or below the x-axis? Okay, so step one, we'll make sure that all variables are on one side of the inequality. We'll factor, and then steps 3 and 4 are where we're going to struggle conceptually. We're going to make something called a sign chart, and then we're going to plug in some numbers to see what's happening. Right, best thing is to just work through an example. Okay, so let's try to factor this. All right, if you're struggling with factoring, that is a skill you're going to need to go back and review. Okay, this is going to factor into x plus 4 times 2x minus 3. That's what the left-hand side factors to. That's greater than or equal to 0. So think about this graph. Think about this parabola, right? So it's going to open up, and then in some way it's going to cross the x-axis in a couple of spots. Because this is saying where is this greater than or equal to 0, it's asking us about these x values. Right? It's asking us about the x values where our graph sits above the y-axis. Okay, so our answer is actually going to be something in interval notation. It'll look a little bit like the way that we write domain. So here's what we're going to do. All right, so think about the possibilities for this. Right, in order for this left side to be greater than or equal to 0, this quantity would need to be positive, and this would need to be positive. Right, multiply a positive times a positive to give us a positive, or multiply negative times a negative to give us a positive. So here's what we're going to do, right? We're going to find our zeros. So x plus 4 equals 0 means that x could equal negative 4. That would make this equal to 0. We could also have x equals 3 halves, right, if I set this quantity equal to 0. That's working back with section 4.3, solving quadratics by factoring. And I want to put those two numbers on a number line. And this is what a sign chart is, right? And so what we're going to do is kind of separate this and see what's going on sign-wise in between these values, okay? So let's pick a number that is like on the left side of the number line from negative 4, like maybe it doesn't matter. I mean, we can pick, negative 100, just anything that's less than that, right? So if I plug in, let's say negative 100, then I would have a negative 100 plus 4. I'm using this simplified version because it'll make the math go a little bit more quickly. And then negative 200 minus 3. And then it would be, negative 96 times negative 203. And I don't need to actually do the math. I just need to see negative times a negative would be a positive, right? So anything going on this side of that negative 4 is going to be a positive. Okay, so I'm going to put a bunch of plus signs there. Thinking about what's going on above 3 halves, so maybe I plug in positive 100. Okay, similarly, I take 100 plus 4, 200 minus 3. I'm going to end up with a positive times a positive, meaning these would all be positive in that region. Okay, and then thinking through that middle, so I need to plug in a number that's in between negative 4 and 3 halves. So let's say I pick 0. Right? 0 plus 4, and then 0 minus 3. I would have 4 times negative 3, which is going to give me a negative 12. So any values that I plug in for x in between negative 4 and 3 halves are going to give me a negative output. Okay, so now I'm going to look back at the original sign. Greater than or equal to 0. So the regions where I'm greater than or equal to 0 are my positive regions, right? So my answer is going to be some intervals. Okay, my interval on the left is negative infinity up to negative 4. I'm going to put a bracket because I have this greater than or equal to sign. Okay, union, I skip over this middle because this is all negative. and then I go back up to positive starting at 3/2 all the way up to infinity, and that is going to be your solution. All right, so it's quite an involved process. This is not easy. This will take some practice, but your answer is going to be an interval, okay? And so what this means graphically, let me pull up Desmos for us, just to try to reinforce this concept. If I plug in that parabola, 2x squared plus 5x minus 12, look at it, right? My parabola is above the x-axis from negative infinity to negative 4. And it's also above the x-axis from 1.5, which is 3/2 to infinity. And then here, I'm below. So that's kind of mirroring what we're doing here. We're just not graphing it. We're only looking at the signs. All right, pause the video. Try this one. Okay, I recognize that we are still new at this, so you probably didn't get very far, and that's okay. All right, first thing we're going to do is move everything to one side. So I'm going to add 6 to both sides to make this less than 0. We got to be working with zeros here. Then we can factor. It's tempting to try to factor with 5 and 1, or excuse me, 6 and 1, but because we have that 5x and positive signs, we got to use 3 and 2. Those are the factors of 6 that will add up to give us 5 in the middle. And so our critical values here are going to be x equals -3 and x equals -2. So when we make the sign chart, those are the numbers that we want to include. Okay, and then now let's plug in some numbers on either side. If I plug in -100, I'm going to end up with a negative times a negative, which would give me positive, right? And then in the middle here, if I plug in a number in the middle like -2.5, okay, I can work this out for us if desired. -2.5 plus 3 times -2.5 plus 2 is less than 0. This is going to end up giving me, let's see, 1/2 times -1/2, which is going to actually be a negative. Okay, so that whole region is going to be negative. And then if I plug in like positive 100, I'd end up with 103 and 102, which is again going to be positive, right? And this time, look at your sign, right? We want less than 0, so we want negative regions. The only negative region we have is here, in between -3 and 2. So in interval notation, we want -3 comma -2, and because we have this less than symbol, we want to use parentheses because they are not included. Okay. Give this one a try. All right, when we factor, we should end up with x plus 6, x plus 5 greater than or equal to 0. Making our sign chart, we want -6 and -5. Plug in some values. Okay, plug in a super negative number, and we'll end up with a positive region. Plug in maybe -5.5 or some number in the middle. We'll end up with a negative region, and then we'll end up with a positive region over here. And again, we're getting that by plugging in values for x either into this equation or into the original. I like to use the simplified one because it makes my mental math easier. And then now look at your sign. We want greater than or equal to 0, so we want those positive regions, which are here and here, meaning that we want -infinity up to -6. We want a parenthesis around -infinity, and then we want to use a bracket around that -6 because of the greater than or equal to symbol. Union, when we pick up again at -5, again using that bracket all the way up to infinity. Okay, that's that. Take a look at your practice. Let me know what questions you have.